everybody. How you all doing? That good, huh? I know, the late nights, the jet lag, the early starts, they're having your brain pumped full of information for 3 solid days. But please give a very warm welcome. Up next here on the Alpha stage is a very dear friend of mine, somebody I'm looking forward to sharing a stage with at the party tomorrow night, presenting the Defensive Coding Bootcamp. Please welcome, she's a principal developer advocate at Okta, which is now part of Auth0, I believe?
Other way around.
Other way around. Auth0 is part of Okta. And you're part of both of them.
Yes. Please
welcome. Oh no, now we get the pre-roll. So this is all for the benefit of the people watching on the internet, because if they don't have this, they might forget they're in the metaverse. That's my theory, right? Heather Downing.
Hello, Build Stuff. I'm really excited to be here, because why wouldn't I be? The stage looks amazing. All of the energy in the room is awesome, and it's nice to see you all in person. And on the internet, welcome. Come next year. This talk was an interesting one for me to write, because I'm a normal developer like all of you, right? I tried to figure out a good title, and all I could really come up with was this one, which is shorter than the other one that I had, which is this. So what I want to share with you today is the things that I learned since moving into the security space and to the identity space, and things that I should have done the whole time as a normal dev. So this is not for security experts, unless you are one, great. But this is for the rest of us who have to really build stuff, right? So what you're going to get out of this is pretty simple. You're going to get some helpful tips on how to be an incrementally more secure developer, so a couple of example scenarios to avoid, some useful non-language specific knowledge, and a quick starting point or checkup before your next project. I have a terrible, terrible memory, and unfortunately, I need to look at my own notes almost every time I start a project. So this is kind of like a good starting point for yours. So the further along that I go on this path in the security identity space, the more I feel sometimes discouraged or realistic, I guess I should say. This kind of learning curve looks a little bit like this. You start off kind of not knowing anything, and no one expects you to know anything, right? And then you get, oh, I read a blog post, or I watched a video, and now you're like, I know what's going on here. You got it. You're going to be totally secure with your code now. And then your site gets hacked, and you're like, oh, well, I guess I don't know everything. And you kind of live down here for a little bit in this discouraging, realistic place. I can tell you that it does take a little bit to bounce up to mastery, but it happens incrementally, a lot slower than the first couple phases. I would say that I'm finally starting to head that away towards mastery after 4 to 5 years, specifically dedicated in this field, and it takes a bit. So this is not to make you an expert. This is just to give you some takeaways to remind yourself of how to be a little better so you're less likely to get hacked. Sound good? Rule number 1, don't always build it yourself. This is so hard for me. I am such a builder, and I want to understand how everything works. Anybody else like that? No, just me. I'm the only one who does that. I used to write a lot of code, and I didn't know that the more code you wrote, the more bugs you have, and the more security holes you can create. Coding at a framework level is going to yield you a lot more secure results than rewriting some low-level module. It doesn't mean that you shouldn't be creative and try that, but maybe don't try it at your current employer. You know, maybe they wouldn't feel great about you leaving the company later and having to figure out what exactly it is you built and if it needs to be constantly monitored for zero-day attacks. Yeah? So that's number 1. Here's a good one. Plan to rotate your keys. Does anybody do that already? See, yet again, nobody raised their hand. So this is an easy one to take back with you on Monday and say, hey, do we rotate any of our keys? Do we have a plan for that? With any sort of shared credentials, you should understand that they could leak. So you need to be prepared with a process in place to rotate them. Okay, so look at how fragile all of these systems are. Here's a good example. The CodeCo supply chain breakdown case study was one of my favorite examples here. This breach was done by very sophisticated attackers who exploited a mistake in how CodeCo built Docker images, okay? They used this to modify a script which allowed them to send the environment variables from the CI of CodeCo customers to a remote server. Sounds a little concerning, yeah? But they didn't think about it at the time when they built it. If you're interested a little bit more about that breach, here's a good URL for you. But all I'm trying to get at is that there were a lot of different pieces that could have just been avoided if there was already rotation in place. A good example that I have done personally is that I just do monthly rotations on the fly anyway, so that gives me just a 30-day window to lock down when an attacker could have come in and got that information. But you should be able to do it on the fly. You should be able to, once you discover that you've had a data breach, you should be able to immediately rotate. And so I bet you this is new for a whole lot of you, and it sounds really complicated, but it's not really. Come talk to me after if you're interested in how to do that in your particular framework. Also, be skeptical about the new library on the block. I mean, some of you already do this brilliantly. I see all the comments on Twitter. But I was not this person. I'm a naturally optimistic person. I want to know the new thing. I'm excited about the new thing. And I want to see if I can build with the new thing. But using a new or immature library can yield really poor results. You don't know who wrote that code, especially if it's open source. It could be several people. And if you can't trust that code on some level, you should not include that in your project. It depends, of course, on how vital your project is. I'm talking about code that makes us money, code that makes your company money. That's what I'm talking about. I'm not talking about your Hello World example you play with on the weekends. I'm talking about vital infrastructure. So if you vet your libraries pretty carefully, popularity, you'll find, does not mean quality. Is there more than just one committer? Are other popular frameworks using that library? Has it been backed by some sort of evergreen open source foundation that will keep it alive if something happens to the original maintainer? These are good questions to ask when you're deciding whether or not to include a library in it. The next slide I want to show you is going to take a little bit to look at. So this is the OWASP top 10 vulnerabilities from 2017, and then more recently in 2021. Notice how a lot of the top vulnerabilities that happen in software haven't changed very much. They were just reordered a little bit. That means that you're not going to always know what you don't know about what kind of attacks you can have, but the majority of these top 10 security issues that developers face has not changed much since 2017. That means you can familiarize yourself with what they are and curb probably 80% of these. Don't you think 80% is better than curbing 0% of them? I think so. The one that gets me every time is that we still have SQL injection problems. Still. Even though there's lots of other databases, there's lots of other kinds of ways to handle data, it's still one of the top ones up there. So if you're interested in that, definitely check out OWASP.org, and we're going to talk a little bit more about them as we go. This one's going to be hard for my introverts out there. I'm an introvert, believe it or not. I'm on the stage because I practice, and I have been coached on how to present, but I'm not a natural extrovert. So I will almost never in a team raise my hand and speak against what my architect has already put together. And this is difficult, especially culturally, because it's just harder in certain areas than others to believe that you actually have a good point to talk about. However, security gets to be one of those. You are at the mercy of the architectural decisions of the places that you've worked for the first parts of your career. That's true, because you don't question that status quo, and you don't know if what is happening is supposed to happen. or if you're just not understanding it, you're just not grasping it. Security is the right time where you can say, hey, do we do this? Hey, should we not do this? Security is the time. You get the permission to raise your hand, because if you notice something and say nothing and then there is a breach, you're going to feel really bad about that. Also, if the architect has really thought about this, and maybe it is true that you just didn't understand how they were putting it together and it is secure, you get to give them the glorious moment of explaining it to you. And then they also get to think about, is this the right way to do this securely or not? So again, raise your hand when you're like, hey, this doesn't feel secure. Maybe I'm not understanding it. Can you give me a little bit more detail? This is the time. But don't be afraid to challenge the assumptions of the stacks you've already learned. It's very likely that the things you've learned are only one possible way of doing things and not necessarily the best. Particular frameworks and opinionated architecture approaches are rampant all over our industry, right? It's better to understand how your framework fits into the bigger world of code or the bigger call stack, okay? Some of the frameworks go too far into covering up what is really happening, and it obfuscates the true flow. This is particularly prevalent in OpenID Connect or anything with OAuth in general, is that there's a lot of frameworks that just do things for you, and even though you might have a plethora of options to utilize, they're very opinionated and only give you one, see? So it's important to know why there's a limitation. Is it a limitation that the framework puts on that flow? Is it possible outside of it? You need to know just a little bit more about what is possible. You don't need to be an expert, but just a little bit more. So you end up completely trusting how your framework approaches security, and you often don't have the ability to audit it, right? Sometimes, at least with the newer versions of the frameworks that I work on, it's easier to kind of step into the code as it's executing, and you can kind of see what it's doing and how it's setting things and where it's going. But again, all of the instructions usually in your docs just say, go do this. They don't tell you why. They don't tell you that there are options and when are the scenarios you would choose a different one. That's when docs are just not enough. You need to know what is possible. An example is an ORM wrapping up a database. So if you're used to using an ORM, you're used to all of the built-in security, and it likely won't expose you to SQL injection, likely, right? But some of them allow you to build custom where clauses in SQL. And you aren't often aware of the security vulnerabilities that come along with that. Or you somehow interface directly with a database and you haven't exercised the muscles of security fencing in a while, if ever. And it's easy to just get things to work and then not realize you just open yourself up to multiple injection attacks. You with me? Good deal. This is everybody's favorite subject, testing. Yay. Lack of test is so surprising at every company that I've ever talked to. End-to-end tests test the UI. Sometimes they'll test your API. A lot of places have no tests. It's so tough to know if a vulnerability can get through if you're not set up for tests in the first place. So maybe consider separating out, at least in what I've found has been useful, is whenever we've had a true security audit, like an external security company comes in and says, all right, we want to see what you've done, and we're going to give you opinions about how terrible your code is and most likely to get attacked. And it's really easy if you just point them to a nice suite of tests that say security on them. It's easier to have them run that and see what it is you've already thought about covering. So I've started doing that now, where like, yes, there are tests for our just our use cases, but I also do one for security and saying, can I get in this way? Could an attacker get in that way? And that way, it's all kind of lumped together and a little bit easier to process, especially when you want to add more. Next thing I learned, oops, there we go. Yeah, there we go. Is that a secure app does not equal secure data. This is kind of like locking your front door and leaving all your windows open. Yes, your door is locked. Good job. But somebody with just a little bit of creativity is probably going to go around back and try your window. And that's kind of how it is with data. I never locked it down so a user could only see their data when I was a developer in my early days. Why would I do that? I was just excited that my API worked at all, you know. And people could just type in a different ID at the end of my API and see other stuff. Just to try it, just because they could. Luckily for me, it was one of my coworkers who did that and not somebody outside of production. So securing your app is one thing, but securing your data is a whole other thing. So frameworks usually give you some of this stuff for free with some of the protections around URLs, but you generally have to write some custom code to secure your data. And don't assume that popular tech is secure by default. Ready for a good example? Kubernetes secrets are not really secrets. They are base64 encoded strings. So you have to look into the tech behind the name. You don't have to just trust anything. You just have to, it's not that you can't use Kubernetes secrets, it's that you have to know what they really are and what they're not. Naming is very tricky. You know, naming time zones, we never get that right. But don't just say, oh, because Adobe does it, then it must be great. Always look into what the tech really is doing behind the scenes. And that shouldn't take you more than like an hour. I'm not talking about deep diving for days. Just look into how it's truly structured. Next thing I learned is that there's more than one way to approach authentication. Who knew? I wasn't an expert in auth or identity when I first went into the company I'm at now. And it's incredibly confusing right away if you don't spend a lot of time on it. The different ways to approach it are numerous, like SAML, don't use it, but SAML, OAuth, WebAuthn, basic authentication. There's different approaches and protocols and possibilities, and understanding those flows is so critical for beginners, because if you're just saying, how do I add login to my Java app, is going to yield you just one type of example, but maybe you really need a different flow that gives you more flexibility. Or you need one that is a little bit more future-facing, so you don't have to touch it every year and constantly update your flow. It does take a little bit, but I highly recommend you spend just a little bit of time looking at which authentication flow truly makes sense for the app you're working on. I learned that incorrect encoding and serializations are still an issue. No matter what I built, it seemed like I couldn't keep up. Just to sound like a Wikipedia article, the term encode, has been used in the past to denote encryption, and it may still carry that meaning outside of a technical context, but in the software world, it's only meant as a data handling mechanism that never provides any measure of security. So just because you encoded something doesn't necessarily mean that it's secure, you just encoded it. While encryption is meant to guarantee data confidentiality, some modern encryption algorithms employ additional strategies to also guarantee that data integrity, and sometimes by means of embedded hashing algorithms as well as authenticity. I'm already losing all my normal devs, aren't I? Just said a lot of words. What I really want you to take away, though, is that it's easy to sound fancy right away, saying, oh yeah, I encoded it or I encrypted it. Did you do it properly? I'm going to show you an example about how to write insecure code. Let's take a minute, look at that. Looks like a good start, doesn't it? I'll give you another scenario that I'll walk you through. If you're a React developer and you call a set of Spring Boot microservices, and you're the functional programs that you are, you try to ensure that your code is immutable, right? So the solution you come up with is serializing user state and passing it back and forth with each request. An attacker notices the R00 Java object signature and uses Java serial killer tool to gain remote code execution on the application server. Here's another one for all your PHP lovers out there. I love this one. I have done this scenario in .NET, so it's not just a PHP thing. The attacker changes just a serialized object to give themselves admin privileges because it's not really that obfuscated. It's pretty obvious. I did that to my own app once, and I was mortified that I could give myself admin access at any point in time as a user. Because everything was chronological. As long as the last call came in and said this, it like unlocked it. Oh, how did that happen? It had to do with how I was saving actions in my database. It had a lot to do with how it was architected. And nobody ever taught me that just because you can code this way means it's secure and safe code to run this way. I mean, if you ever go through a boot camp, like a coding boot camp, not just going to a formal college, if you go through a coding boot camp, nobody has time to teach you about security. We just want to make sure you can actually execute anything to run. Right? So don't feel bad, you're not expected to know this. But check this out. Just check out if you have just some basic holes in your encryption and encoding. And the fun one, I learned, do not use insufficient hashes. Many cryptographic algorithms and protocols should not be used because they have been shown to have significant weaknesses or are otherwise insufficient for modern security requirements, shall we say. Would you like some examples, just so you can cross-reference on Monday to see if you're using any of these in your database? Sure. All right. How about this one? MD4, anybody? SHA-1? I use SHA-1 all the time. And once I discovered that it's actually pretty easy for hackers to break that, I went, that's a lot of projects I got to update now. Just because it's available doesn't mean it's safe to use, especially if you have a very lazy framework team that never removes insecure hashes ever from their libraries. They just add on more. So if we are human, which I think most of you are in the room, then you're going to use that neural pathway, whatever is familiar. If you're going to go down the hashing algorithm list when you're selecting it, and you're going to pick SHA-1 because you've picked it before, right? Because you're like, oh yeah, I used that before. So something you can do if you are feeling like a hero is do a nice pull request against your framework saying, it'd be great if you took that out so I don't accidentally select it. Because it's just a lot less secure than more modern hashing algorithms. I mean, isn't that how log4j kind of got hit? I also learned that code you wrote with time will become insecure. It's a fact of life. At the time, it probably was stellar, and it was the best you could have done and have researched. Security is ever shifting and changing, so it is exhausting and endless. Yes, that is true. How do you know, though, if the thing that you wrote last year is still secure? Let's just go 1 year back. I'm not talking about the one you wrote 10 years ago, although I'm sure you've all worked on code much older than 10 years. So NIST is good for this because they write standards every year that you can use to audit things. So PCI is also a good one to use for leverage with your company or management team to be proactive instead of reactive to vulnerabilities. We used to call this technical debt, but it's not really technical debt if it worked right in the first place at the time. If you build in an update amount of workload and be proactive about it, then you're never going to fall into this technical debt area, at least in terms of security. You might with your company's use cases, but security should not be anything you sacrifice. So if you use the industry's current standards to back up the need to attend to and maintain your application at your company, then the decision to execute is not in your hands, and you don't have to take it to heart. It's just a company risk decision. That was one of my favorite phrases to use, saying, okay, well, based on what we're seeing for the upcoming year and how hashing algorithms have changed, and maybe we need to do a little bit of work, I just wanted to inform you, my boss, my manager, that leaving it that way is a company risk decision. Usually, they'll at least add one more meeting to your calendar to discuss it further. Just remember, your job is to explain the risks and bring the evidence. It is their job to decide. And if you're interested in how to have a framework to talk to your CTO or manager, go to nist.gov/cyberframework. The framework is voluntary guidance based on existing standards, guidelines, and practices for organizations to better manage and reduce cybersecurity risk. In addition to helping them, it was designed to foster communications against both internal and external stakeholders, meaning that the security company that your company is hired to audit you to see if you're a good developer or a bad developer, those people. This framework is set up to bilaterally be able to communicate about what is important. Remember, this is adopted worldwide, and it's volunteer-driven. There's a lot of good frequently asked questions on this site and guidance for small businesses on things to keep in mind. When I discovered this, it was a godsend, and I sent it to almost everybody I knew, saying, if you don't know where to start, here's a good one. That's a good one. Another thing that I learned is really cumbersome, but true. Validate everything, every time. Don't ever believe what is coming into your system. Always validate it. Think about trust boundaries. When data flows across a trust boundary from outside your system to inside your system, you shouldn't trust it. Why? Do you trust that your database hasn't been breached? As the dev, how do you know that somebody didn't just change a bunch of data and put a bunch of scripts inside of your database that now, because you're pulling things from a database, are going to run in the browser and execute for your user? How do you know? This is a moment where you need to start collaborating with your data team. And if it's just you, if you are the data team, collaborate with yourself and be like, okay, so what should I expect from my database? What should I expect from my browser? What should I expect from my service? And make sure you have validation across both sides of that flow. String comparisons are red flags, but I liked doing them. That was a fun line of code to write. But you can get string comparisons very wrong. And a lot can depend on character encoding and regular expressions just missing some malicious use cases. So if you've got a lot of string comparisons here, see if there's just a different way that you can go about putting your data where you need it to be, or evaluating that data to display whatever you're displaying or redirect your user. Because you should never assume that the user is going to follow the use cases put out. I know it's disappointing to us. We feel like it's crystal clear, and they somehow managed to screw that up. I'm not talking about the people who can't use an iPhone properly. I'm talking about the people who can use many phones and computers properly and are just finding a way to trip you up. Don't assume that your user is there with positive intent. There are cheat sheets out there to inform a hacker how to input SQL injection. They don't need to memorize it. Try to account for all the possible edge cases. It's kind of fun, actually. There's a great talk you can find online from Troy Hunt called Hack Yourself First, and it describes how you can kind of be like your own hacker and attacking your stuff. A great thing that I learned is that you can be lazy and secure. I bet you're all ready for this one, yeah? All right, here's how to be lazy. Do input validation. For instance, just allow letters in the username field. There are shortcuts to this. You don't need to hand code all the things. Just using a vetted third-party authentication option can remove a lot of risk from your shoulders. Sometimes it makes sense for you to do it yourself, but not always. This was an interesting experience learning about that different cultures have different threat issues. You need to understand where they truly come from. So I talked to a good friend of mine who hosts DEF CON in the States, and he gave me a scenario that went like this. One of his biggest screw-ups was related to physical security. He made a bunch of threat assumptions that might be the same in the UK and the US, but he also did that for like South Korea. Threats like RAM raiding just do not happen in Asia. Has anybody ever heard of a RAM raiding? Ooh, I get to tell you. A RAM raiding is literally how much force it takes for a car to drive into a window at a shop and steal everything from like a Gucci store. But that just doesn't really happen in Asia. That happens more in other countries. So he was countering threats that weren't even the cultural norm for them. So he was like prepping them and made sure that the glass was this big and they have an additional security system. And that just wasn't the threats that they were experiencing at the time. So what may be normal for you may not be in another place. That being said, 80% of security is a common body of knowledge. There is quite a bit that all of our apps have in common. Although a specific industry might think that they are more unique than they really are. For example, my favorite one to quote is how automobile companies think that they are different and their industry is in a silo and they don't have things like hackers going after any of their code. They feel like their requirements are very specific to their industry. So if a vulnerability is not labeled as automotive tech specific, then they'll ignore it. They don't feel like they need to pay attention to it. But 80% of security is a common body of knowledge. It's just like the 20% layered on the top that is specific to the industry. I mean, and if you follow the OWASP top 10 examples, you would have covered 80% of security vulnerabilities already. If you work in the automotive industry, are you not creating an API? Are you not using a UI? They're all still the same kinds of things. So if something hit a browser that's vulnerable, the question is, does the browser run in the vehicle? Ever? Yes or no? What stack are you using for that? Was that stack specifically hit with a vulnerability? You would think that multi-million-dollar corporations would be on top of this, but I can tell you that's not the case. So that means it's up to us, the normal developers, to raise our hand and say, have we at least looked at the OWASP top 10 for this project? It will make you look like a superhero. You should try it tomorrow. This one's not my favorite one to learn, but I had to. You have to get your head out of the code a little bit. The more you're in it, the less you can see the big picture. When you're focused entirely on the project and just what you're working on, you're not paying attention to all the other places that insecurities are coming from before they reach that piece that you're working on. This also, ironically, can make you a better architect. Architects have the ability to see the big picture, to see how things can plug in. But you can do that at your level right now, whether you're a junior, a mid, a senior, or whatever. Whatever your role is in the company is irrelevant. You should be able to ask questions of your project team to get that big picture. Because if you don't have it, how in the world are you supposed to see the headlights coming that's going to hit your project straight on? And if you're not sure, find someone you trust and have them take a look at it. You need somebody that can look at the whole project. It can't just be you. Get another pair of eyes. One that you not only trust, but hopefully actively collaborate with. There are no stupid questions when security is at stake. This can be really hairy because there's a lot of very private repos out there, and if you don't have somebody on your team that can truly help you look and have a little bit more expertise than you as to whether or not what you have written is indeed secure, maybe you should ask outside of your team. That can get a little bit tricky because maybe you need to have them fill out an NDA, you need to have them fill out some sort of paperwork, and then HR is involved, and it sounds like a hassle. But if you don't feel 100% confident that what you've written has been thoroughly vetted by somebody else other than you, I would just bring it up again as a necessary part of mitigating company risk. These are great words to use with decision makers. Have a trusted person take a look. If you can't do it, suggest that we give somebody else access that can take a look to make sure we don't miss anything. And this is on top of just someone testing your code. I mean, as you go, maybe you have a check-in every so often. See what you can do, because this may feel like you are admitting to your company that you don't know everything. But remember, security moves so fast that no one can know everything. It's better to have somebody else who's not close to the project look at it. because they don't have any inherent biases of how things were supposed to look. So they're going to be able to give you a lot more information that's actually helpful. Anybody mess with cores? I like to say that it's code for to do. Everyone has dealt with cross-site scripting errors unless you've only ever lived in the wonderful back-end land and never ever dealt with a browser. Most people do hacks to get around cores. They forget that they did that, and then they build the rest of their project around that being the working environment situation. Then a hacker comes in later that exposes it. And when you try to fix the core's vulnerability, suddenly your project is broken by design. Does it sound familiar to anybody? No, just me. I've worked with an awful lot of developers where I see them do this exact thing. I just need to get it to work. Let me just do this in place. And then you kind of forget that you put that in place. The best way that I can say to mitigate this is set up cores properly in the beginning, then forget about it. Just, if you have to run into what machine you're on and a bunch of allow listing, that's fine. That's real life. But don't build your project in an open, insecure environment. Because then you're not going to know how things are going to perform later. I very strongly believe that you need to start with security and then build your use cases. Because then you're already inside of that box. You know, you're already inside of the things. You don't need to bolt it on later. Often that's when everybody hates it. They're like, oh, now I have this 401 error. Oh, now I can't get in. Now I'm not authorized. Now I can't do this. Yeah, because you built this entire project without even thinking that you would have to interact with security in some way. Okay. I don't know one company out there who would love to be insecure because it's easier. I think right now most companies are pretty terrified of any of their code allowing hackers in. So do cores properly. And verify that your environment has bare minimum security. So brute force attacks can also happen on your projects. Sometimes they cost you money. Hackers will often hold databases for ransom just by running a list of commonly used admin passwords. Does anybody take a guess as the commonly used admin passwords for your database? Admin is still, to this day, the most common pairing because we just don't want to deal with it. Oftentimes, when there is no database administrator, it was the developer who isn't a DBA and just was like, oh, just let me into the database. I'm not going to change the default. It's also often not stored in a password manager. There are basics you can suggest to your network admin, DBA, and or developer team handling deployment person and be like, hey, I know we have this Google Doc out there that has the list of how to get in to our server. Could we put that in like one password or something so that it's not accidentally discovered on our drive somewhere? You might be laughing like, do people really do this? Yes. Yes, they do. I'm at a company that has also experienced this with our third-party vendors. So I can tell you that suggesting a password manager is probably a really good place to start to handle all your stuff. It feels like at first you're like, oh, I have to get this started, but it's so much better, especially for that security audit that you're going to get one day, to say all of our passwords are in a password manager. It's not written on a a wiki somewhere. It's not on a Google Drive somewhere. It's in there. You're going to get 5 stars. And be transparent immediately. I was very uncomfortable admitting that I did something wrong. Sure, that's just a me problem, right? None of you have that issue at all. But you need to sound the alarm right away once you discover a project's been hacked, whether you worked on it or not. You need to send it up the chain, and don't try to outsmart the hacker and be a hero. Once that happens, you might have to get like a legal team involved, all the way up to the owner of the company. And at this point, you just need to ask for help when something like this happens, and just don't interface with them yourself and try to suddenly close that door, unless it's that rotation of keys that we talked about earlier. You should do that, for sure. But don't try to be the hero, because at this point, they don't want to talk to you. They want to talk to the people with the real money. I want you to ask yourself this question. What do you wish that you had known about coding defensively? Notice that none of this makes you a super hacker. This just makes you be less of a target, or at least an accessible target. There's a lot of different things you can do per platform. So if you're a JavaScript developer, there are specifics to you that you can do, but a lot of these should apply anywhere. I want you to consider the first time that you really discovered the process you were doing was just not that great. Maybe you're in your early days and you haven't had enough exposure yet to discover that. I promise you, a developer somewhere that you will work with will be happy to point out that something was wrong. So instead of feeling bad about it, I want you to take it as a wonderful example you get to tell a bunch of people on a stage years later. Because none of us really want to go into this job doing a bad job. It's important for you to understand you are not a bad developer because your code was insecure. Again, most of us didn't go through training on how to pick the better approach. Also, what is the best approach? It changes every year. It changes every 5 years. What used to be secure is no longer secure. How do you keep up with all this stuff? Again, one of the better ways to mitigate that is to check out what OWASP can give you on a basic level, and then ask around a little bit more in your community. That means you have to step outside of the company you work at and see which direction things are heading, and maybe get examples of other projects in the same stack that have gotten hacked. You don't, again, this is not you becoming an expert. This is just you becoming curious about what's possible. If you're interested in using this as a nice little starter notebook of things to look at, I'm happy to share my slide deck with you here. And the one thing I want to leave you with is this. Even if all you do is go back to your team on Monday and raise your hand and say, are all of our server passwords in a password manager? You're going to be on the list for a promotion in a year because you just saved the company a bunch of risk mitigation just by that one thing. Don't be afraid to raise your hand and ask, why is it like this? Instead of just assuming that you don't know and you're not smart enough to know why they architected the spaghetti code the way they did. It's okay to challenge respectfully, and often that will give you the responsibility the next time around. So, you got this. I'm looking forward to hearing all about your much more secure coding experiences. Thank you.